Talking about systems of equations. This time we are going to be talking about the substitution method. We've looked at graphing already, and so we'll try something new this time. But first, let's warm up practicing, what do you think? Substitution. So copy these into your notes. I want you to pause and I want you to substitute the value x equals -2 into each of these equations and solve for y. All right, pause and then come check your solutions. All right, let's see how you did. I'm going to pull the shade down and check your solutions. Make sure you kept your negatives straight over here. Make sure that you did your algebra right, that you added and subtracted from both sides, that you divided all terms, and you came up with these solutions. All right, now why are we looking at substitution? Well, it turns out substitution is another means of solving a system of equations. What is a system of equations? Think about that for a minute. What is it? It is two or more equations with the same variables. So do we have that here? Yes, we have two equations and they have the same variables, x and y. So we've looked at how to solve this with graphing. Let's look at another method, this time without graphing. Now you could graph these and solve for sure. See, this is slope-intercept form, y equals 3x plus b, b is 0. This would be at the origin, slope of 3. And you could also graph this equation. Find where they intersect. And what is the solution to a system of equations? It's a what? A coordinate, right? A coordinate, x, y values. That's what we'll be looking for. All right, so what's interesting here is when you look at these two equations, you see this first one is y equals 3x. It tells us what y equals. It says y equals 3x. And this bottom equation is x plus y equals 8. And you see that y is in both of these equations, so is x. And it's really interesting that we see that y happens to be 3x. So can you guess what we could do in order to get an equation with only x's in it? Stop to think about that. Could we get one of these equations to have only x's? Because if we did, we know how to solve that. All right, maybe you've thought about it. If we take this term 3x, we know that that is y, so if we just replace y or substitute y in the green equation, equation number 2 with 3x, we could find x. So let's do that. Let's substitute into the green equation. So we have x plus, and now instead of y, we are going to write 3x, because that's what y is. Y is 3x equals 8. So what do we do now? Well, we can combine like terms and solve this for x. So this will be 4x equals 8. Divide by 4 on both sides, and we will have x equals 2. Well, that's pretty neat. We found out that x equals 2 by substituting in. Now, that x is 2, can you think of how we can find y? Well, now that we know what x is, we can put that into either of these equations and we can find out y. So let's do that. Let's say y, and I'll circle this here so we just remember we found x equals 2. Y equals 3 times x. Well, we'll substitute in. So this is from equation 1 right here that we are substituting into. Y equals 3x. X is 2, so we substitute in, and y equals 6. So we have now found a solution. We found an x and a y value, which will be represented as a coordinate. So x, comma, y, 2, 6. Now we could then check our work on this, and it's always, again, always a good idea to check our work. So let's do that real quick. Y equals 3x. So that would be, if this is x and y, if y equals 3x, we would have 6 equals 3 times 2, and guess what? That's true. 6 equals 6, so our work checks out. And we will then check the other equation. X plus y equals 8. Well, that would be 2 plus 6 equals 8. Sorry, that's a weird marker right there. 2 plus 6 equals 8, and 2 plus 6, well, 8 equals 8. There we go, it checks out. So let's go over what we just accomplished there with substitution. Oops. With substitution, we found another way to solve a system of equations. So the steps we took. Well, the first thing we had to do was make sure that one of our variables was in terms of the other. So what that means is that we had the situation where it was y equals or x equals. And that's what we have here. We have y equals or x equals. So let's note that right here, step 1, we have y equals 3x. So that means one equation for one variable. So solve one equation, y equals, and we could substitute in. So the next thing we did was we substituted this expression into the other equation. So that was this step right here. We recognized that y was 3x, so where y was in equation 2, we just substituted for 3x. Next step, we solved for the other variable. We found x. After we found x, we could substitute that back into the first equation or the second one, and we found y. So that was our fourth step. Finally, and I'm just going to get rid of the shade at this point, we put it into coordinate form right here, 2, 6, and we checked our solution. Always check your solution to make sure that you have done your work correctly. All right, so that is the substitution method, 5 steps. Let's do one more together. Okay, so this is a little more maybe complicated situation. We'll look at it. Nothing you can't handle though. So let's see if our first criteria is taken care of. Do we have one variable that is set equal to an equation, a variable by itself on one side of the equal sign, so we know what it equals? So look at equation 1. Notice that b, and it's on the right side this time, so be aware of that. B is all by itself. We know what b is. B is 2a minus 17, which means we can substitute it into equation 2. So we'll now substitute this expression into the other one. So b is 2a minus 17, so when we get to b, we'll substitute. So we have 3a plus 4, and now at this point, we will substitute in our equation for b, which will now give us an equation only in terms of a. And since there's one equation, one unknown, we can solve this equation. So 3a plus 4 and the rest of this equation, well, how do we do this? Well, we've got to distribute, right? So let's rewrite this. Let's simplify. 3a plus 8a minus 4 times 17. I'll have to do some mental math here. I believe that is 68. And that equals negative 13. Okay, next step, we need to combine like terms. 3a plus 8a is 11a. And we will write the next line. Now let's add 68 to both sides to isolate the variable. So 11a equals, in this case, we will get 55. So finally, and this is a much longer one, right? A little more complicated. Stretches your algebra skills going back to the beginning of the year. Well, we will find that a equals 5. All right, so we found a. So the next step is to plug that back in to either equation to find b. So let's plug it into equation 1 since that already has b by itself. So we will take equation 1. Let's just copy that and move it down so we can look at it. Oop. All right, so equation 1, down here we're going to substitute in a for 5. So we know that a is 5. So let's substitute in 2 times 5 minus 17 equals b. So that will be 10 minus 17 equals b, and negative 7 equals b. For a solution, remember the solution to a system of equations is a what? It is a coordinate, right? So our solution in this case, and it's not x and y, but we'll go in alphabetical order, a and b. A is negative 5, b is negative 7, so our solution is 5, negative 7. And I'll leave the check up to you. Always check your solutions. You're good at that by now, so leave it up to you. All right, you've now got 2 methods. You have graphing and you have substitution. We'll see you in the last video for addition and subtraction.